A developer loses a laptop in an airport. The disk is encrypted, but their SSH agent had loaded a production key that morning, and that key was also copied to a second workstation months ago. Your server sees a valid public key and opens the door. No password guessing, no noise, no obvious lockout event. This is where SSH two-factor authentication earns its keep. The key proves possession of the private key, and the TOTP code proves the human has the enrolled authenticator right now. Today we are adding that second step without breaking every admin and cron job. For SSH, the clean pattern is not password plus code. It is public key plus a short time-based one-time password, usually called TOTP. The key remains the primary credential. The code is a second gate after the key succeeds. OpenSSH can require multiple authentication methods in sequence, and PAM can ask for the code through KbdInteractiveAuthentication. The common Linux implementation is the pam-google-authenticator module. The name is historical. It works with standard TOTP apps, not only Google Authenticator. Each user enrolls their own secret, usually stored in their home directory, and receives emergency scratch codes for recovery. The key directive is Authentication Methods. When you set it to public key, KbdInteractive::PAM, SSHD does not accept either one alone. The client must first complete public key authentication. Only then does SSHD continue to KbdInteractive, backed by PAM. PAM loads pam-google-authenticator, reads the user's secret file, checks the current TOTP value, and returns success or failure. The order matters. If the key fails, the code prompt never appears. That reduces information leakage and keeps random internet noise from burning user attention. It also means your login will show which stage failed if you collect auth logs properly. This is the core shape. On Debian or Ubuntu, install libpam-google-authenticator. Then have each human user run Google Authenticator inside their own account and save the emergency scratch codes. In /etc/pam.d/sshd, add auth required pam-google-authenticator.so. If your Debian PAM file still includes common auth, leaving that include in the auth path can create key plus password plus code, not key plus code. Decide intentionally. In SSHD config, UsePAM must be yes. KbdInteractiveAuthentication must be yes. Password authentication can stay no. Authentication methods is one line, public key, KbdInteractive::PAM. Run SSHD-T, then reload SSH, not a blind restart. Here is a safe rollout for one admin host. First, confirm you have console access through your cloud provider, hypervisor, IPMI, or a local terminal. Second, keep an existing root or sudo SSH session open. Third, log in as Alice and run Google Authenticator. Scan the QR code, answer the prompts, and store the scratch codes in a password manager or sealed break glass note. Fourth, add the PAM and SSHD config lines. Fifth, run SSHD-T. Sixth, reload the service. Now open a brand new terminal and connect as Alice. You should see the key accepted, then a verification code prompt. Only after that test succeeds do you close the old session. The first mistake is doing this over your only SSH session with no console path. Do not. The second is using the pam-google-authenticator nullOK option for a staged rollout and then forgetting it. NullOK means users without an enrolled secret can still pass. That may be useful for one maintenance window, but it is not your final state. Third, automation accounts cannot type TOTP codes. Treat them separately with narrow keys, forced commands, source restrictions, or a match user block that requires public key only. Fourth, protect scratch codes like passwords. Fifth, keep time synchronized. TOTP tolerates a small window, but bad NTP becomes an outage. SSH MFA is not a replacement for key discipline. You still need unique keys, passphrases, agent lifetime control, disabled password login, and clean authorized keys files. MFA sits on top of that. It is especially useful for interactive administrator access to bastions, production shells, and shared management hosts. It pairs well with log-level verbose, central auth log collection, and alerting on repeated keyboard interactive failures. It also connects to account lifecycle management. When a user leaves, remove their key, disable the account, and remove or archive their TOTP secret. MFA improves the blast radius, but it does not fix abandoned accounts. For practice, use a disposable VM you control. Create a test user with a working SSH key. Take a snapshot. Install the PAM module, Run Google Authenticator as that test user, and save the scratch code somewhere temporary but private. Add the PAM line and the SSHD config drop-in. Run sshd-t. Reload the service. From a second terminal, SSH to the VM as the test user, and confirm you need both the key and the TOTP code. Then test a bad code and watch the auth log. On Debian, that is usually /var/log/auth.log. On systemd systems, journal ctl-u SSH may help. 3 beats to remember. First, SSH two-factor authentication is best done as key plus code, using authentication methods to stack public key and keyboard interactive through PAM. Second, enrollment is per user. Generate the TOTP secret, store the emergency scratch codes, and never enable this without a console or break glass plan. Third, automation accounts need an explicit design, not a surprise outage. Use exemptions sparingly, and compensate with tight key scope. Tomorrow we continue the Practitioner arc, with another SSH administration and defense topic. New SSH Mastery episode daily on this channel, plus the daily ranked CVE brief for what needs attention now.